Hi, welcome to our session at DevSecCon 24. We're here to talk about avoiding infrastructure as code misconfigurations. Everything you'll see in this session is open source by checkmarks. You're welcome to check our code, security policies, and feature requests on GitHub. Of course, you're welcome to join us community as well. Here me, I'm Lior Kaplan, head of open source for checkmarks, and here with me are Ori and Mark. Ori?
Thanks, Leo. So let me introduce myself. My name is Ori Bandit, and I'm the Director of Product Management. And together here with me is also Mark.
Hi, guys. My name is Mark. I'm a Software Development Manager at Checkmarks.
%42%. This is the number that I want you to remember. And what does it mean? It means that probably your infrastructure's code contains at least one misconfiguration. And this is coming from a research that we will talk about later today. But in a research that was done in 2020, almost half of the CloudFormation configuration file had at least one insecure configuration. And today we are going to talk about how you can prevent those misconfiguration as early in the cycle as possible using kicks. So let's start with the basics. Let's try and understand what are cloud native applications. So here you can see the cloud native definition from our friends at Cloud Native Computing Foundation, where they are saying that cloud native technologies empower organizations to build scalable application. The technologies contains containers, service mashup, microservices, immutable infrastructure, and declarative APIs. And if you are stating for an application to be cloud native, it is specifically designed to provide consistent development in an automated way across the different clouds, and in some cases also a combination of the different clouds. So what is the difference of cloud native application compared to traditional applications? Where cloud native system, the application source code that we are so used to scanning up till now is becoming only one building block. It's only one piece of the puzzle, where cloud native applications is saving and managing everything as code. It's obviously still the application source code, but much more. We see container, we see orchestrators, we see network, we see firewall, and as we are going to talk today, also infrastructure as code. And if everything is now code, we can benefit from managing it as code. It means that we can automate it, we can apply GitOps practices, we can have code reviews, we can run different tools and analysis on that, and we can test it and make sure that it is up to the quality that we want. Forrester refers to it as going beyond the traditional definition of code. And in their last Forrester wave that was released last quarter in Q1 of 2021, they defined that when developers, the fact that now developers are using infrastructure as code to define cloud configuration, and once you and your company move to this new type of code, you need to find the right tools to scan those new type of vulnerabilities and in those new type of code, going beyond the traditional definition of code. Now let's talk about what is infrastructure as code. So infrastructure as code is the process of managing and provisioning software through machine readable definition file, rather than doing this work manually or in interactive mode. If we were talking about 5 or 10 years ago, so the development team would finish the development, come to central IT and tell them, listen, I need this infrastructure, I need this database, this application instance, and a couple of weeks later, IT would come back and bring them this infrastructure, and then they would be able to deploy their application. And infrastructure as code allows us to simply automate this entire process, making sure that it's up to date and it can keep up with the speed of DevOps or DevSecOps. Infrastructure as code allows us to speed up, reduce the cost, and eliminate the inconsistency, simply because we are using the same recipe or the same configuration over and over to deploy the same infrastructure using the same tool in the same manner. However, as we saw at the beginning, infrastructure as code security is a concern. In a research that was done by Unit 42 from Palo Alto last year in 2020, they tested over 200,000 different infrastructure as code templates, and the findings was very troubling to anyone who cares about application security or infrastructure security whatsoever. As we saw, so the first thing, and you can see here the link to the full research, 48% of the AWS S3 buckets did not have any server-side encryption. 42% of CloudFormation, as we discussed, had at least one insecure configuration, and 55% of the cloud user-defined S3 buckets did not have any logging enabled. And we are going to talk about today, what does it mean? How is this possesses a threat to your application and to your infrastructure, and how you can prevent those upfront. So this is a typical cloud architecture. I'm sure that all of you have seen other more complex, more simpler cloud architecture. Everything is covered in the VPC, the virtual private cloud. We have the gateway, we have some load balancer, we have the WAF, the web application firewall, the application instances, and obviously also the database. And with that, a corresponding or an example of an infrastructure as code file. Here you can see an AWS CloudFormation that deploys simply a sample application on AWS using AWS CloudFormation. Obviously, the web is full of other very useful resources and example, but this is just one example. So this concludes kind of the intro. So we talked about what is cloud native, what is the difference of cloud native application, what is infrastructure as code, why is it a concern, and now let's see how you can solve it and how you can prevent those infrastructure as code security risks. So I will now hand over to Mark. Mark, go ahead.
Okay, so let me introduce KICS, which stands for Keeping Infrastructure as Code Secure, open source engine that we developed in Checkmarx. KICS scans and finds misconfigurations and potential vulnerabilities in infrastructure code. It supports all major cloud providers and infrastructure as code technologies, such as AWS CloudFormation, Ansible, Kubernetes, Terraform, Docker, OpenAPI, and gRPC support is coming soon. We can see here that KICS is finding security misconfigurations by applying security policies across different types. We can see here that it finds things related to access control, availability, insecure defaults, network and firewall, everything that is important to us in order to be confident when we're deploying our applications to cloud providers. It has great coverage and supports more than 1,500 of security policies. We can say that its coverage, the most coverage in the market at the moment. We can see here a simple example of vulnerability that KICS can find. Here we can see the SSH port 22 is left open, leaving the possibility of unauthorized access, port scanning attacks, and remote takeover of our infrastructure. So once we introduced KICS and understood better how it works behind the scenes, let's see some demo. I will share my terminal screen. And I will start the KICS scanning. On the sample project, which is called TerraGot, which contains different vulnerabilities, the report is going to be HTML report, and we will take a look how it looks like. So here we can see a short summary of findings spotted by KICS. We can see high severity vulnerabilities, medium ones, and also low informational vulnerabilities as well. So once the results are saved to HTML file, we can actually see how it looks like. So those are KICS results. We can see the summary of vulnerabilities across different severities, and we can see all those examples of things that are important to us to find before we are deploying our infrastructure to cloud. For example, we can see here DB instance, which is accessible to the entire world. We see something related to storage encryption, which could be important to us to make sure that we are encrypting. We can see things related to public access to EC2 instances and many other things that we find with the help of Kix. So once we have this example of running Kix in an ad hoc fashion, let's see how we can integrate it in our CI/CD pipeline. We can go here and see the example of Kix integration into GitLab CI/CD pipeline, in which we basically have two steps. We have the step of running the Kix on our infrastructure, and the second step is basically parsing its result and understanding if we have vulnerabilities that we need to fix before we are applying our infrastructure to the cloud. So we can see here that the job was in a failed state, and it happened because we found high severity vulnerability that we are demanding to fix before we are deploying our infrastructure to the cloud. So this is basic example how Kix could be integrated into our CI/CD tools. And in this one, we saw GitLab integration, which is really intuitive and easy to follow. So let's go back to the presentation. I will share my slides again and give you a recap of what we just saw. So we saw basic integration flow in which we had some changes done by developers on one side, committed to the source control, to Git, to any other source control repository. And from there, the CI/CD pipeline is starting, runs Kix in order to make sure that we don't have any security vulnerabilities and misconfigurations. And once the check is passed, we can safely deploy our infrastructure to the cloud environments. So let's talk about some advantages of Kix. First of all, as we mentioned previously, it has the largest infrastructure as code security policies coverage. It's really easily extensible, and you can add your own queries and policies in an easy way by using Rego language. In addition to presenting the problem, Kix also presents the solution, so we can learn what we need to fix in order to resolve all findings that Kix has found for us. The architecture of Kix is really simple and robust, and you can add more cloud providers and more infrastructure as code technologies in a really easy way. As we said previously, Kix is an open source project. You can find it on GitHub repository. We have really extensive documentation that you can follow in order to get started with Kix. And we can also chat with us on GitHub. If you have any suggestions, any feature requests, you can go ahead and chat with us on there. Here you can see the QR code. Just go ahead, scan it, and you can easily find Kix on GitHub. Please don't forget to start Kix on GitHub. It will really help us to promote it. Thank you very much. That was it from my side. Thank you.
Thank you, Mark. So now, after we've seen Kix live and understood how it can help you, I would like to share with you a couple of more minutes of all the resources that you need in order to have Kix up and running. The first thing that you need in order to have it up and running is getting to the website, which is kix.io, that possesses all the information that we just discussed and much more. As you can see which are the supported platforms, what are the attributes that Kix has, and most importantly, the link to our documentation that will help you to get started. And I do encourage you to go directly to the installation guide that brings you on the different deployment method, whether it's the Docker, the binaries, or simply forking the source code from GitHub. It also possesses all the list of the queries. So what are the policies? What are we supporting? What is the documentation? What did we base these queries on? You can obviously download it and share it with a colleague or forward it to your manager. And each of our queries come with the documentation, meaning this is the reference on what we base this query or this policy on. Beside that, it also has all the different integration. So whether you want to have it running as a pipeline on your Azure DevOps or your Bitbucket, Jenkins, GitHub, or anything else, everything is there and documented well, so you can have it up and running in a matter of minutes. If you are interested on general Kix things, including the roadmap, the plans, the issues, everything that we have, you can see it here available in a very nice and intuitive way. If you want to start contributing to Kix, we have the guide on how to get started with the contribution. If you are looking to write your own policies and queries, then we also have the guide for that as well. The queries, as said, are written in Rego. You can work with the Rego playground. This is very helpful and very easy. So once you get the hang of how to write the queries, how to write the policies, you can add, you can keep them on your own private repository, or we do encourage you to contribute back and to open the pull request so we can integrate that with the rest of the current policies and queries that we have. Also available is the architecture. So if you are looking to give us a test drive and check what is under the hood, so this is definitely available and all the information that you want in order to understand how Kix works. Beside that, I also want to share with you our repository. So it is, as mentioned, a public repository under the under the main checkmarks account, open. You can see everything, the engine, the queries, the policies, everything is available there. We are releasing a new version every 2 weeks. So always make sure that you have your own latest version. You can see the roadmap here, what we're currently working on, links to the getting started, and how to reach us. So whether it's on Gitter or you can send us an email, everything is available. If you find an issue or something that you didn't like, or if you are missing something, then we do encourage you, please open us an issue or a bug or a feature request on GitHub. And we do take the feedback from the community very seriously, and we are very, very responsive. You can also see what the teams is currently working on, what is currently in progress, what is already done, and what we have in the backlog. We are splitting it into the Kix queries, the policies, and also the engine itself, so you can see both of that as well. I also want to show you one example of our queries, the policies themselves. So as mentioned in the advantages, sorry, each query comes with its own example of how to remediate. So beside the metadata of each of the queries, as you can see here, what is the severity, what is the query name, what is the platform, what was this query and policy was based on. It also comes with a test information, both positive and negative examples. So if you will scan the positive example, Kix will find this vulnerability, and if you will scan the negative one, that it will not find. And this is very helpful information to help your developers with some of the remediation. So these are the things that I wanted to share with you: the website, the documentation site, and the actual repository. As Mark mentioned, if you like us, if Kix helps you, please give us a star. It will really help spread the word. If something is not working for you, you don't like it, something is missing, please reach out to us on Gitter. We are more than happy to get any feedback that you have. We already previously implemented a lot of feature requests that came from the community, and we are very responsive to those requests. You can take a look at our recent releases and the changelog, so you can definitely check and see that we are investing a lot of effort in the feedback that is coming. And with that, I'd like to thank you for joining us for this session. It was a pleasure of presenting here in DevSecOps 24. If you have any questions, we're more than happy to answer them now. And thank you very much for listening.